Hello there. This time I've dug out a Eurosonic Euro1, and I've done that because some of the sets use the same chassis. There's the Eurosonic Euro2, there's the Alba CBM1, and there's the Harvard 400M. So by doing this we cover 4, and this is the last of the regular videos. I've probably said before, our other business is in church pipe organ restoration, and that kicks off full time tomorrow. So we put the radio side of the business to bed for 6 months and solely concentrate on pipe organ restoration. However, there will be 1 or 2 requirements to supply radios during that period, and so I will of course furnish those requirements, but chances are we'll only be able to do 1 CB video per week for the next 6 months. So there you are. We started this on was it the 1st of January? Right. I've cheated. I've had another member of staff, because time was of essence today, put a new power lead on this and also make up a mic for it, and to make sure this is actually basically works. So I'll just open this up. We'll pause the video while I do so. Okay, this printed circuit board has the identifier CB240 there, and so this chassis is used in, I say, quite a number of sets from 1981. It has a transmit receive relay which can play up, especially if it's been in a smoking environment, and I've got a chart which I made at one time for the adjustments here. I can do the VCO with you because we've got a full service manual. The service manual I'm using is for the Alba, and the Alba is always identified because it has the slider controls and a vertical meter, not to be confused with those awful Harvard good buddies. So we'll say we've got a full service manual here. Because of that, I'm able to do the VCO with you, and it's quite simple to set up. The radio uses an LC7137 from Sanyo, and I'll just set up the meter and we'll come back to you. Okay, I've located test point 1, which I will zoom in on a moment. We're going on to channel 20 on this version, on this radio, and then we adjust transformer 10, which is the VCO, for 2.2 volts. So going into transmit, we've got 4. Well, having done that adjustment, we've got a totally different voltage to what's stated in the manual. We've got 3.99. That's the test point just there. It says test point 1. I've got 1.8 on receive. I've got 3.9 on transmit. And it doesn't want to adjust from there, but the radio works. I've also monitored the voltage on pin, I'll just zoom out a bit, on pin number 17 on the LC7137. And I'm getting 1.8, which is exactly the kind of thing I'd expect on channel 20. I'm just going to check channel 40. I've got 2.6 on channel 40. And I've got 1.2 on channel 1. So that's what the kind of thing we're looking for. So it must be set, but it's not doing it as per manual. It says high impedance voltmeter, and because it's doing a digital one as I'm using, it is indeed high impedance. So I've got no further comment on that because it's not setting up as the manual, but it is set up by monitoring the voltage in those two ways. Right, so that was a bit of a not a good demonstration. So we'll move on to transmit, and our first port of call on transmit is transformer 2. Okay. And transformer 2 is that one there. Now right at the moment we've got 3.1 watts. Now this looks a strange order, but this is the order it says in the manual. And then we move on to transformer 4. And onto transformer 9. Onto transformer 8. And then, unusually, on this radio, I did those two in the wrong sequence. It's 4, followed by 8, and then 9. So just make sure I am correct on that. And then we move on to VC1. There's a variable capacitor there. That's brought it up to about 3.5. I'm just going to backtrack on these again. So we're still at 3.5, and that's it. I seem to recall that one at the back there is 54 meg adjustment. We don't have the information. We don't have the could do with the spectrum analyzer for that, to be honest. So that can stay well alone. So it's doing 3.5 watts. So that's probably a good 4.5 good buddy watts. So these are commercial instruments I'm using. They tell the truth. Right. So we better just check that we've got the meter reading a similar kind of amount on the front. So when I press transmit, it's swinging to the centre of the red section, which is correct. Now the transmit meter adjustment on these radios is the variable resistor there, which is variable resistor 1. On this occasion we don't need to touch it, so that's variable resistor 1 is the RF meter. Now what I don't know is, do these have adjustable low power? I do not know. I'll switch it to low power, the switch is there on the back. The radio is doing what? It's doing over half a watt, it's supposed to be 0.4. Now, I don't know what that control does. I don't know what that control does. I don't know what that control does. But I know that's deviation. So I'll tell you what, we'll have a fiddle about, because whatever we do, we can put it back right. And that is the low power control. So I'll guess that right. So that's variable resistor 6. I'll now amend my sheet to say low power. And next we'll do deviation. I'll just get the little oscillator out. Switch the other camera on the right hand oscilloscope there. And we should have 2.5 kHz deviation. Variable resistor 2 is deviation. There we have 2.5 deviation. Do the whistle test. Do it just a fraction more. Wallow. There we go. These have a Roger bleep on them. Just put the monitor receiver on. Testing 1 2 3 4 5. And on this model, the Roger bleep isn't switchable. On the Euro 2, it is switchable. So we need to check the radios on frequency. It should be 2779125 on channel 2779128. That's absolutely fine. And if we needed to adjust that, then it's VC2, which is just down there. Just switch the camera off. And I think that concludes the Eurosonic Euro 1 on the transmit section.